So far, we've learned about the basic structure of a smartphone logic board. Now it's time to take a closer look at the components found on that board and understand what each one actually does. When you first look at a smartphone logic board, you might see hundreds of tiny components that all look similar. But don't worry. In this chapter, we'll go through the most important electronic components one by one and learn how each of them works. Let's start with the resistor. As the name suggests, a resistor creates resistance to the flow of electrical current. But that's not its only purpose. Resistors are also used for things like dividing voltage, adjusting signals, and controlling different parts of a circuit. In smartphone repair, even a tiny resistor can be extremely important. If one fails, it can cause an entire function of the phone to stop working. Next, we have one of the most common components on a logic board, the capacitor. A capacitor can temporarily store electrical energy and release it when needed. One of its most important jobs is helping stabilize voltage and reduce electrical noise in a circuit. There are many capacitors on a smartphone logic board, and some are so small that they're difficult to see without a microscope. The next component is the inductor. Like a capacitor, an inductor can store electrical energy, but it works in a different way. Inductors are commonly used in power circuits and voltage conversion systems. On a smartphone logic board, you'll often find them around power management circuits and voltage regulation sections. Understanding inductors will become especially useful when we start working with power-related problems. Now let's take a look at the diode. A simple way to think about a diode is as a one-way path for electrical current. It allows current to flow more easily in one direction while restricting it in the opposite direction. Diodes can have several different jobs on a logic board, including circuit protection and signal control. Understanding how a diode behaves will also become very important when we start using the multimeter for testing. Another component we may find on a circuit board is the fuse. A fuse is designed to protect a circuit from excessive current. If the current becomes too high, the fuse can open the circuit and help prevent further damage. However, modern smartphone boards don't always use traditional fuses. Depending on the circuit, different protection methods may be used instead. Now let's move on to a more advanced component, the MOSFET. In simple terms, a MOSFET can work like an electronic switch. A control signal can turn it on or off, allowing current to flow or stopping it from flowing. MOSFETs are commonly used in power management and many other circuits on a smartphone logic board. Understanding how they work will be very important when we start diagnosing power-related problems. The next component may look simple, but it can play an important role in digital circuits. A crystal oscillator provides a precise and stable frequency. Many digital circuits need an accurate clock signal to synchronize their operation, and a crystal oscillator can provide that timing reference. Later in the course, we'll take a closer look at how these components are used in different circuits. And finally, we come to one of the most important components on the logic board, the integrated circuit, or IC. An IC is essentially a complex electronic circuit packed into an extremely small package. Smartphones contain many different ICs, each responsible for specific functions such as power management, charging, audio processing, and wireless communication. In later chapters, we'll look at some of the most important ICs found on smartphone logic boards and understand what each one does. Now you have a basic understanding of some of the most important components found on a smartphone logic board: resistors, capacitors, inductors, diodes, fuses, MOSFETs, crystal oscillators, and integrated circuits. You don't need to memorize everything right away. As we move forward, we'll see these components in real circuits and learn exactly where they're located and how they affect the operation of the phone. From here, we're getting closer to the most important part of board-level repair, figuring out what went wrong and finding exactly where the problem is.